people that we're doing things that interest people and that people feel like they're making progress. Any, bef- you know, let me say this differently. Today, I plan to show how the equivalent of classes works in Rust and methods on classes. Um, what we have seen so far is, well, we showed you how to set up an environment and import modules. We did some control flow exercises, and we did a bit of the borrow checking, the borrows and references. And that was our last three um, sessions. We can review all of those of it today if people feel that they want some review, or I can jump into other topics. But otherwise, I was thinking of doing effectively, uh, yeah, classes. What does everybody think?
That sounds good. I just wanted to add something because I went through and was doing some of the error handling, trying to do a pull request. Um, and something that may be helpful for others is Daniel. He shared a document like about error handling, which was really useful. And then I added that to the notes. And then I think is it what's his name? Seamsec has been reviewing. Also had another document I haven't gone through yet with error handling, which I will add to the last week's links for anybody who's interested in doing some of those previous tasks.
That's great. Yeah, thanks for surfacing those resources. That's awesome. Um, and Wade, I mean, shout out to Wade. I mean, first for organizing the tool scrubbers and giving us all the infrastructure we need, and but also just an amazing just waterfall of work you did. On the error handling. Really cleaned up a lot of things very nicely this last week, and good job, man.
Thanks. I will add, it wasn't just me doing it. I had help from GitHub Copilot. I don't know if anybody's used it,
Oh wow.
um, but
Yes,
it's
sir.
super helpful. It's like I think you actually have to pay for it. It's like maybe $10 a month, but it runs through while you're coding and helps with what you're doing. And it's like it's AI. So it doesn't do everything correctly, but it gives you a good foundation, and then you can double check your work, sort of thing.
Yeah, it's really awesome. I got the invite and I've been using it for seems like a month now. So it's pretty wild how it'll finish your code and your comments sometimes, or it'll make code based off of the comments that you write right above it.
No,
Yeah.
cut it out.
Yes, it is insane. I'm actually yelling at my desk more. So
Yeah, I've been meaning to do it. I wasn't sure how useful it was in like lesser used languages like Rust, but it sounds like it's amazing.
yeah, I've been using it for most of the stuff here is like in PHP. So it'll even do some of the SQL commands like writing SQL and working with PHP. It'll actually like complete queries, and it is wild. Really good to have.
Yeah, I think it uses from like what I gathered in that last exercise, it uses the preference of the repo as well. So it will use prior comments and things like that within the repo that you're actually coding in, um, which is kind of interesting. So it's learning as it's going, but also helping quite a bit.
Amazing, amazing. Um, okay, so until we have AI solving all of the problems for 0L, we're going to need to train new engineers. So I think we can get started here. What does everybody want to hear about? I can do some review. I know there's some new faces here today. Welcome. don't be shy or write me a DM. What would you like to see again? And I can spend 10 minutes on review.
From my experience with just doing the error handling, maybe it's good to go through the different types of error handling. I was kind of using Match to begin with, but then CMSEC had also, he also let me know that maybe expect could be a better option to use in certain cases. That may be something we could cover. That may be
Yeah,
useful.
okay. We can do a bit more of error handling. I think we'll do that. We'll do some error handling, and we'll go through the borrow checker again, because Sirach asked me a question last week or some more time ago. He gave me an example, and I couldn't solve it, immediately just by looking at it, and I had to like sit down and like open it on my browser, sorry, in my VS Code to actually solve it, and I'm glad you did, because it did show I think it was educational for about the borrow checker.
Yeah, for me
Um,
too. Thanks for hitting that up.
Yep. No, I think I'm glad you surfaced it. And then I think the one ID. Yes. Hi. You asked last time. You wanted to see. You asked about difference between str and strings, and I said I would get to it, and I never did. But I do think it's a good example.
Yes.
For borrow checking. Strings are a bit weird. I guess in all languages, but in Rust, the defaults aren't. The defaults aren't obvious. So let's see. I need to share my screen. Let me know when you guys can see this.
Looks good.
Yep. Cool. So I'm going to be using the tests, the test annotation. Danielle had asked me about this, and I think it's good practice to. You guys probably know this from other places you've worked on, but test-driven development is great, So I'm just going to run this one. I'm just going to run this for a second here, just to make sure everybody remembers how to run tests. So in VS Code, we get these helper buttons that show up in tests, but if you're just in the terminal, cargo T will run your tests. Yeah. I had actually put tests in another place. So when I do this in VS Code, I have been lately just hitting the test button right here, and getting my tests output at the bottom. Again, dbg is a debug print, which will handle most things and format things for you. And it'll also give you a link to your code here, so you can find stuff. So that's why we use debug when we're doing when we're just developing, rather than a print statement. Okay, so we're going to do a bit of error handling. So we made two functions. So a couple weeks ago, we wrote two functions here that just import a module time and give us and return a TM object, TM struct type. And then we just do we hard code a flow here, but depending on the logic of this function, it's gonna either error in the case of a result type, it's either gonna give you the answer or an error, or in the case of an option type, it gives you the answer or none. So we say none. And so in Rust, again, we're very conscious of memory safety. We want to know when everything is initialized from the start with Rust. We don't want things that are null or uninitialized. If there's a risk of something not having the data we need to explicitly make it an option type to wrap the data we want and give it a none. So there are no null types in Rust. Okay, so in my test, I'm calling this getTime function we did above, and the getTime is an option. Returns an option type. Yeah, and so here it's a true statement, so I am returning a sum. So sum is a variant of option. I'm returning a sum of the thing I'm interested in, which is this year field. This year field from my object TM. So so what that means is that I can use the unwrap method of the option type. Yeah, I can unwrap it into something else. So let n equal this, and I can debug n. And this is, not great error handling, but it is error handling. Yeah. But what happens if I run this and it's a false instead, and I'm forcing it to return a none, and I use the unwrap, Rust is gonna protect me and say, well, you actually are unwrapping something that's not there, so we're just gonna panic, and you're gonna get this ugly panic code. So it's not great error handling. So what you want to do is, it's not giving very good information over here. It's just saying called I called an unwrap on an unvalue. I'm not supposed to do that. So what are different ways that I could handle this? So Wade, you had said expect. So expect is a variation of unwrap, where I can put a message in there. This is wrong. Yeah, and so now when I run it and it panics, I still get the whole panic trace, but instead of I'm trying to unwrap an option, I get the actual message I'm expecting to see. So it's still panicking, but it's panicking with a message, so that might be better, but it's still not right for systems type development. Like, unless we actually want the system to panic, and there are some cases we want to do that, but we rarely do. We usually want to handle things. And so for the option type, and it's basically the same for the result type. For the option type, we have one option we have one alternative for error handling that's different from the result type. But let me just show you this other function we have, which is the getTime, but returning a result. I'm just going to change this here. So now instead of it returning an option, I have a result type in here. Let me make it fail as well. So this fails, and now I'm going to run it and see what happens. It also panics again. So, but now I'm not only getting this is wrong over here that I had put in the expect. It's actually giving me this other error here, which I had coded above here. So with result types, I'm always giving some expressive error back. So this is why results are generally better than returning results is the pattern you generally want to use for systems level things, where you want to know what the error is and then maybe how to handle things depending on the error. Because because with the option, we're just finding out if I'm expecting to have a number here or not. But for functions where you're actually doing different things and you might have complex logic, you might get different errors depending on different things you're doing, and you're going to want to know the error. And we'll get into that a little bit further in other classes. But so anyway, the unwrap and expect are you can use on both result types and option types. So unwrap is the same for result types. Yeah, but this time it just panics and gives me that ugly error. So what do I want to do? What's the thing that the way I do error handling generally is I do match. So I can assign something with a match as well. So I can match, what am I going to match here? I'm matching T for its cases. And sorry, I use VS Code to fill this out for me because I'm lazy. So fill match arms. I need to put a semicolon at the end. So now I'm assigning n based on the two cases, the two conditions, the two variants that a results type can be. And a results type can be of variant OK or a variant error. So now here I have the, sorry, and I can name the variable that comes back that is wrapped in the result. That's wrapped in the OK, so that I can use it on this side of the case. And this is just a block of code. You can do anything you want in it. So I'm going to do a debug of the result. Sorry, here. And then the error, same thing. I'm going to debug the error. Okay, so here, and this, if you've different programming languages have different ways of doing this. So in coming from JavaScript and Node, this is the case, and so Rust lays it out very neatly, the different cases you can have, and allows you to destructure the variables as well, and basically create a closure over here. So if I run this now, instead of it panicking, I see my test actually passed. My function still works. Like it didn't abandon the thread. It said, well, it did exit successfully because yes, while you did have an error, you told me how you wanted what you wanted to do with this error. You just wanted me to print it out. Yeah. So if you actually see here in the test, I actually have two debug prints in my console. I have the oops, there's an error, and then I have an n equals nothing, an empty tuple. That's because it didn't. I didn't assign anything. So in my matched case, I can then. Now I'm going to assign something in my case. So I'm going to return an I64 here. So in the case of the correct result, give me the result back. Assign it to n. In the case I don't get a result, just give me a 0. Yeah. And then if I now run this, I force it to fail. So it says, oops, there's an error. But now I get the assignment to 0 equals 0. So I'm going to stop here for now. I know I've been going on for about 10 minutes here. Wade, is that what you wanted to hear? And does anybody else have questions?
Yeah, that was perfect. It sort of covered like why you would maybe use an expect instead of a result.
Yeah.
I have other questions, but yeah, I'll let other people speak.
Cool. I'm just going to do something very quickly then. Anybody else have questions? Okay, I'm going to go back to the option type, get time as an option, and I'll show you another error handling that you do here. This is for just option types. This uses, you should just consider this sort of a, there are a lot of things I could say about this, but you basically just see this pattern everywhere. So it's the if-let pattern. So what does this mean? It's just an if statement. And if it lets me do this assignment here, then do whatever. But this assignment, what I'm doing here, I'm actually doing a destructuring. I'm actually taking the T, which is a wrapped option, and I'm saying if it is a sum type result, then let's assign the inner part of it to this variable val, and then give me a debug of val. Yeah. So that's the same thing. This is also better than using unwrap or expect, to Wade's question, because it allows you to handle it in the case of an error. In the case of an error, it just does nothing, you know. And so it's only checking for when something actually exists. This is a very common pattern you'll see throughout the code, the destructuring of an option type, and then doing some code in that block. So I'll stop here. Is this enough for recap of error handling?
Yeah, I think so. That was really good. Thanks, Eddie.
Cool. Super. So I'm going to jump in and try to do a recap quickly on borrowing, because, like I said to Sirach in the chats, if you do anything with Rust, if you're going to spend time on anything, spend time understanding memory. This is going to be especially important for people who come from even Java, but also from interpreted languages. You know, if you're coming from Node and you haven't used TypeScript, well, TypeScript doesn't really help you with that. If you're coming from interpreted languages, this is all going to be very foreign to you. And you know, even in Java, you're not really dealing with memory to the extent that you are with C++. And so Rust is very special in this sense. It makes a lot of safe memory choices for you, but you do need to understand memory, how it handles memory, how it's opinionated in memory management. So let's do, how had we done this? Now I'm gonna have to do it from scratch. I'm still gonna use my tests, but okay. Here's a variable v, which corresponds to a vector, and this is how we generally instantiate simple vectors in Rust with a vector macro. There are other ways you could do it. I think it's vec_new. You could do vec_new as well. Generally, people use this macro. So what is this vec? This vector, so it's basically an array of a type. And what this is doing here is it's creating a allocation in the memory on the heap part of the memory. It does two things if you're familiar with memory. So there's in memory, you have two parts. You have the stack and the heap. And the stack's a limited amount for fixed objects generally, and then the heap is dynamic generally. So I'm sorry, I'm oversimplifying things, folks. When I'm doing this here, what I'm doing is I'm creating a pointer on the stack to a space in the memory with the bytes of this vector, so on the heap. And so this vector can increase or decrease. So that means this is memory that's dynamic in here. So that's what a vector is in the memory. sometimes I want to access this vector. For example, when I do a debug print, I want to access this memory. And this is just fine. So I just run it, and I get my printout of the vec. Yeah. But what Rust does is it says it doesn't leave memory, let memory accumulate. And so in other languages, you have garbage collection to make things go away. So you proactively search and destroy things. But with Rust, is very opinionated. When something goes out of scope, generally, it's consumed. It's no longer available to us. So if I'm going to do the same thing again with other languages, you would expect to get a second print here. But in Rust, you can't do that, because Rust proactively says, we don't want you to be reusing objects in memory once they've gone out of scope. They don't exist anymore. So what exists in Rust is the idea of borrowing and taking a pointer, effectively taking a reference to the memory. And that's what you do with the ampersand sign here. So if I run this now I got the print I was expecting, getting 2 prints. So what's happening here? So this is the important innovation of Rust and the opinionated nature of Rust with memory management, which is whenever I need to use some piece of an object in memory, I'm generally going to consume it when it's out of scope. But if I need to use it and then still have it back in the scope again, I'm going to lend it out somewhere. So the term is, this function, the function underlying this debug macro is borrowing the memory. And it's doing that through a reference. It's doing that through what is a pointer. It's sharing the pointer to the vector. Yeah. And what this means is let's do this differently. Let B for borrowed equal this. Yeah. And so now this will run again. But now I've instantiated this, I've assigned this new thing, I've created this new thing in our memory, B. So this B goes on the stack, the small part of the memory that isn't dynamically sized. And this B is just a pointer to what already exists on the heap, which is the actual vector. So just to recap, I've got 2 pointers now on the stack. I've got V pointing to the original, to the memory that's in the heap, vec. And I've got B, which is another pointer that is pointing to the same vec. So I'm going to stop here because this is, and again, this is advanced stuff, like this is why Rust is a difficult language. People getting tripped up on the borrow checker, it's going to take time to internalize it. So ask questions. Like this is the time to ask questions on memories.
So E would be pointing to the same. I'll have the same pointer on the stack because it's borrowing from V.
That's a good question. I think there are 2
You're
pointers.
passing it as a reference, right? You're passing V as a reference, and you're assigning B. That value, it's not a copy. It's the literal same object in the heap.
On the heap, yes. On the heap, it's the same thing. So we only I don't have any duplicates on the heap when I've done this.
Okay.
I just have one thing on the heap with 2 ways of pointing to it.
I'm a little bit confused, maybe with a more basic concept that I just don't know. because I mean I would have said, okay, if these are copies, then if B and V are copies, two different objects on the heap, then it's fine. It's we can debug both of them, no worries. And that's how I would have understood it. But anyway, you said when the object is fallen out of scope. My understanding, which is probably wrong, would be that the scope of this thing goes from the beginning of the function, let's say the first curly brace, or how you call it, up to the last one. So why debugging B is taking B out of scope? This is something that I don't quite understand. Why is it destroying B?
Yeah, and let me change these names here because over the recording it's not gonna do very well. So I'm gonna have vector and I'm going to have reference. Oh, I can't do it. Say RF here. Because debug, what's behind debug? Let's open it up. Debug is basically wrapping an eprint line, which is okay. I'm not getting to the actual function underlying it, but this is effectively calling a function, and Rust is then passing into this function the object, and then the object is now in that scope. So now, sorry, let's keep it simple. Start from the beginning here. So I've just got V right now. Then this is fine. This runs as we expected. But what Rust is doing, it's what's called passing ownership of V out of the test this scope into the debug scope.
Okay, that makes it clear.
Yeah. So the outer scope is not the owner any longer. Debug is now the owner. And once it goes out of scope in debug, then it's done. Can't access it anymore. So, and thank you for asking the question so I can be more clear with my language. Sometimes we want V to come back to the outer scope. Yeah, but how do we do that if we're passing ownership always to the other scope? Well, you don't then pass ownership, you pass a borrowed, you lend it so that it can return, like the name implies, right? I'm just borrowing it for the purpose of this function. And then when it goes out of scope, return it to here to make sure it's still available for this scope, the outer scope. How's that sounding, Michael?
Yeah, that sounds perfect. Thank you.
Ausgezeichnet.
Question: Are you just letting it? Are you just lending it to RF, or and never taking it out of scope, or are you actually returning it to scope?
Let me see. What I'm doing is it's only borrowing it. So the debug scope does not have ownership of it ever. It only has a reference to it, and it's limited in the things that it can do. So the ownership is still in the outer scope.
Okay.
If that makes sense.
Yeah, it does.
Okay.
Thank you.
So I had done some work last time when we did this. We had two functions with borrowed number and owned number here. I remember, yeah, okay. So, sorry, there's someone else that wanted to say something. Anyone? Okay, so I've got two functions here. You know, this might get to your point, Michael, that you had asked me about. I've got one function which takes, as in its signature, it takes vec u64. It takes a vector of type integers u64. So it takes an owned object, this one here. This function takes an owned one. This one above, the borrowed number, takes a ampersand in front of the vec. Yeah, so it's taking a reference only of it. And so when I call it when I call them in my function, same thing is going to happen. So and own. Okay, so comment this for now. So this would work as expected. I'm assigning, so I've got my original v, my owned v, and now I'm passing it into a function of owned v. And this will be fine, right? And all I'm doing in here is doing a debug print in there, but I could be doing other things. And then the same thing is, and then for the borrowed, if I tried to do the v with the borrowed, the compiler is going to catch this, yeah? Because right here I'm passing an owned v into something that's expecting a borrowed. It's not going to let me. It's saying, look, I'm expecting a borrowed thing, but you gave me the owned thing, the original thing. And so I have to put an ampersand in front of it for it to even compile. And so this is the way that you know and the compiler knows that there are only certain things you can do with that number in here, with that object in here. You know, you're not going to be able to destroy it. And in this case, and in the case with Rust, you're not able to mutate it either. You can make it a mutable reference. So that's, I can go into that next, but let me stop here to make sure everybody's following along. And let me just make this maybe extra clear. I'm going to try and do the owned number twice over here, and I'm going to get the same failure as I was seeing before, because this object got consumed, and it's not back in the scope again. But if I had the borrow in front of it and just the owned, that works. And then I can do the borrowed one as many times as I want. And I'll get all of that. I'll stop here again. Anyone? Okay, so I'll do just one last thing and then we'll jump into the new material for today. We do want to do this example from Sirach. Okay. There's another thing that's called a mutable borrow. So I can change this borrowed. If this is going to do it, I'm going to push a new number at the end of it. This is so. I can sort of, think of this as in real life. You can say, well, you can borrow this thing, but you can't change it. I once got somebody upset at me that I tuned their guitar once they had lent me their guitar, and I didn't understand that. So sometimes you're going to lend something to somebody, they don't want it changed at all. But sometimes you're going to lend someone their guitar and they say, that's fine, you can tune it, you can change it if you want. So in this case, I'm going to need to make things mutable. And so I need to make this vector, first of all, I need to allow it to be mutable, and then I need to pass a mutable borrow to it. So we won't get too much into that today, but this is possible. You see now it's printing out 1, 2, 3, 4 instead of 1, 2, 3 in my borrowed. And then I'm going to print it out of scope here. I get the same. Yeah. So this is how you would ordinarily move things around so that they can be changed, and then without changing the owner, so you could use it again outside of the scope. I'll stop here for questions because the next thing I'm going to do is similar.
Just to clarify,
Sorry, somebody?
you can reference. Yeah, I'm asking. I wanted to ask, like, so you can reference like an owned variable multiple times with no consequence.
Yeah, I can't hear you very well, CJ. Can you speak up a bit?
Can you hear me then?
Oh, sorry, can't hear you at all now.
Hello.
I think
Yeah.
the question was about referencing the same object multiple times without doing any harm to the object, as far as I understood him.
Exactly, exactly.
Yeah, so if you just want to borrow something multiple times, no change, nothing will happen. Yeah. So I can do this, let's see. Let's do the example I did again. So I'm going to keep pushing the number 4 multiple times into this borrowed, but mutable variable. Yeah. So you see now at the end of it, I've got 4 number 4s at the end of it. So if that helps, CJ, does that help?
Yeah. That's, can you hear me? That's what I wanted to clarify.
I wonder if you're following, if that is the best practice to do. Because in my mind, when we borrow something, we don't want to usually change the element.
Sometimes you do, and sometimes you have to. So it's going to really depend on your case. Like there are times when you have a class that you want to a data structure that you want to be augmenting with data, but and so it has to be mutable. But then you're going to need to use methods that don't take ownership of it, that are just using the reference to expand and increase the fill in the data. And we can do that. I mean, I'm afraid we're going to end up running out of time for the thing I wanted to do today, but yeah, I mean it's a pattern. Like you sometimes need to and want to do it like this. But generally, Rust wants you to make things immutable as much as possible and make it go out of scope as much as possible for safety. Which is why we have to, this is different from any other language you've worked on, you have to explicitly say that something can be mutated. Because ordinarily Rust will say, well, then it's just static. Until you tell me I need to mutate it, it's just a static variable.
Yes, makes sense.
Sirach, do you want to set up briefly the chicken fryer example?
Yeah, I could do that.
I might do something just before you do that. The one ID, you had asked me what's the difference between string and str. And strings are weird like that. It's the same thing as the vectors that we just saw, right? Strings are just bytes on the heap, right? So when I do a string new I, when I do this, why are you complaining? Turns out I don't know how to instantiate strings. How do I instantiate strings? From, okay. Here we go. What is this doing here? This did 2 things in the memory. We have to remember the stack, static, things that aren't dynamic, and then heap, dynamically spaced memory. On the stack, I've got a pointer now to a thing on the heap, an object on the heap, with 2 letters high. You know, and it's just saying that this is encoded as a string in the memory. So 2 things: the pointer and the actual object of memory. High. If I want to get a, but when I do this, and this is the thing that's really confusing about Rust, and I do this, high, see how my VS Code is giving me a hint on this? It's giving me an and str, ampersand str. What is str? I mean, it's the same, so this is a similar thing that we saw with vex. It's a pointer to something, right? But in this case, it's weird. So this is what's weird about Rust starting is that, and this is a safety feature of Rust. This is not throwing high on the heap. So it's not going to the same place as this one above. It's not going on the heap. It's actually going into static code. in your binary, going to static memory. So this is just a convention, some magic that Rust does, so that your strings are always initialized somewhere. And so what this convention is, what you're doing here is you're assigning a static string somewhere statically in memory, like in your code. It's actually in the bytes of your code, and then it's creating a pointer to it. Okay. And then, just to be clear, if I do A, I'm getting a reference to a string. Except that you can this reference to a string and a pointer to a string are effectively the same thing. So you almost never see, almost everything in Rust you see is defined as an ampersand str for when you're having a reference, when you're using a reference to a string. That's the easiest thing to remember. Strings happen to be complicated how Rust set it up, but the thing to remember is that string is dynamically typed, and it is the object in memory, and then whenever you borrow string, it is effectively an str is always a reference to a string. This is the sort of annoying. This is an annoying thing about Rust, but you just get your head around. String is the owned object in memory. Ampersand str is the reference to that string. The
Yeah,
one
okay,
ID, did that answer you? Yeah.
Yes, because when I start learning the string part, I read that actually Rust has like 6 or 9 representation of string, but mostly we care about 3. He mentioned str and string in a borrowed version with this, which is this one that you showed, and this one located on the heap. But as I was playing around, I just created a literal string, and then I got this ampersand set there in a borrowed version, and I was like, why?
Yeah.
And I was, why? When do I get to use just the str, the ampersand
Yeah.
str?
Yeah, I think it's needlessly complicated. But that's the thing, is when you're doing a string literal, it's always giving you a reference, and this is not mutable because this goes hard coded into your binary. So instead of it giving you assigning an actual string, it's by convention just it's giving you the pointer to it. It's annoying, it's complicated, but it makes so that the program knows at the start how big this is. It's important for memory safety.
But then I have the question: is there any moment that we get to use just the lowercase str?
No.
No.
There is. So you mean just this, like this? You'll
Yes.
never see it, and it's almost just a reserved thing. I mean, now we're getting into some more details. When you're actually instantiating this string over here, the string capital S this here, what it's actually doing is it's encapsulating a str, is the way to think about it. So what string is, this is a pointer with an str on the heap. And what a literal does is it's an str in immutable memory, giving you a pointer to it. It's not intuitive. I mean, my best advice is just remember string is the owned object, and ampersand str, that's the borrowed object, and that's all you need to know.
Yeah, works. Thank you.
Yeah, yeah. And feel free please study this, folks, if you're interested in this wrinkle here, and correct me if I'm wrong. But we get into a similar thing. I guess we're going to use all of our time on this today, on memory. So, which is good. We need to get this clear. Sirach, do you want to just set it up for us? What the issue is?
Yes. So I'm used to passing as a reference, and with like PHP, where I'd be able to pass as a reference, and then making a change to the variable that I passed in would have an effect on it if it was referenced after. Let's say if I passed it to a function, referring to the variable after would result in the changed value. That's the way that PHP handles the scope and what you do when you pass as a reference. But with Rust, I'm just like learning that you could pass it in, make a change to it, and do a similar type of thing. But I wasn't sure how to set that up really, and that's why I asked you. I was like, what do I need to do? And then you explained the difference with mutable and immutable properties.
Right. So we're going to fry some chicken here, right? So we want to do.
Yeah, good example. Yeah.
So we've got a string of the original chicken over here. And so what have we done in this first line? Let's just make sure everybody's following. I put a dynamic string on the heap, space of memory that can be bigger or larger on the heap, and a pointer in the stack to that. And that's what chicken is. Yeah. And so I'll just run this and it'll print original. Yeah. Let's make this clear. Type of chicken. This is how we do template strings. Type of chicken. Okay. So it gave me the type of chicken original over here. Let's suppose I wanted to change that in a function and then still have it back in the scope like we've done before. Yeah. But I want to change it. So there are a few ways that we could do this. So let's do like, and I think, Sirach, this is the right way of doing it. So let's do a simple fryer. Do I want to do this? I don't want to do this. Okay, this gets to let's go one step at a time. So I've created this thing in memory, this string. So I got the original type of chicken, and now in the scope, I want to push some characters, and I'm gonna say original, but now fried. Yeah. And now I'm gonna print the type of chicken again. Okay. One character.
I think it's push. Is it push string?
Is it push str? Yeah. Okay. Thank you. Original.
It might be push string, but yeah, might.
Well, this was the autocomplete I got. Let's see. Yeah. There we go. Processor. So now I've got 2 originals here. Yeah. What I meant to say. Okay. So that's what happened. So I changed this string. I've pushed onto it. What's going on here? So nothing's changed to my stack. I still have a pointer to a object in memory string that says the word original. But since it's in the heap, it's a dynamic thing. I can expand that container. So now I'm going to expand that container. I'm going to push to it. I'm going to say, but now it's fried. And so this is fine as it is because I never lost ownership of this string. It's still in the same scope. I'm doing a bit of magic here, guys, but like, you know, take this part first. So now I'm able to change this, but sometimes I need to pass it off to another another function to do that. So let's see. I'm going to put it in my friar, and now I'm putting a mutable string in there. So one way to do this is, well, I'm borrowing a mutable string over here, and then, but now instead of pushing to it, this is the difference. Now I want to, I know I want to completely change it. You know, I don't want any mention of it. I want this completely new string to take its place. Now this is where we start getting into a little bit of a more complicated topic, but if I were just going to try to assign this here, yeah, so I've got my parameter 1, a, let's keep this, maybe let's keep this simple. Say, if I had passed this in, and now I'm going to assign something to it, you know, see, VS Code is already complaining to me here, but if I run this, it's not going to compile because it's going to say, you're assigning something that doesn't match over here. You know, I need this to be a mutable string over here. So, but then even if I do that, I'm going to get all these other complaints, which is, you know, you're basically trying to assign things and use them at the same time. So what's the problem here? It's because I'm trying to assign a new piece of memory to a reference is what's happening here. And I can't do that. I can't assign a new string, which is supposed to be on the heap, to just a reference, which is this pointer on the stack. I can't do that. What I need to do is I need to do what's called a dereferencing. So that's what this asterisk means over here. I think this will do it. So if I dereference param, it means what I'm saying here is give me the original thing, give me the chicken, and then, you know, overwrite the memory with this thing here. So this will work. But so this is an important concept in the borrow checker, which is I can't just automatically assume that the point that when I assign something to a pointer, it's going to know what I want to do. So if I want to assign to the thing that's underlying the pointer, I need to tell it to do that. I need to dereference. I need to say, I want you to actually find this thing here that's underlying this word param1 and create a new, overwrite the memory.
So
And so
the
now-
mutable. I'm sorry. I was just gonna ask real quick.
Go ahead. Yeah.
The mutable declaration in the friar function. That's just telling it to expect. That's telling friar, the function friar, to expect the mutable string.
Hold on. Let's do an experiment here because I don't.
Right.
think.
Is it
Oh no,
necessary?
sorry. No, that's right. I mean, our example here is about what's the problem with trying to assign an object thing, so the thing that belongs on the heap, a dynamically typed object, to a reference. It doesn't work. I can't do it. I need to tell it to give me the underlying thing. If this were not mutable, let's see. Let me just double check my understanding of this. Yeah, this should fail because I'm not allowed to mutate it at all. So the compiler knows, look, you're trying to dereference this thing, and it looks like you want to change it, but you're not allowed to dereference and change a thing if it's not if you haven't made it mutable. So don't even try it. That
I had a
all making
question.
sense?
Does the so you see how on line 16, the declaration of mutable string, is that telling Rust to expect that in the pass parameter, or is that actually apply? Doesn't
No,
it tries? It's not transformative. It's just like an expectation.
yeah. It's the type of this parameter. It's
Mhm.
you know.
Okay.
Yeah. In the function signature, we're saying this is what we expect to come in. Param1 has to be of this type, a type string reference, which is mutable.
So it's
Otherwise, the
constrained.
compiler.
It's constrained to that type.
Yeah.
Otherwise, it'll complain.
Yeah.
Okay.
Yeah, the types. Rust is very strict and annoying with the type safety. So I'll stop here. I know we're over time. I can stay on a little bit longer for folks, but I know for new people, new faces you've seen here, this is like hard to follow. I mean, I started in Rust a couple years ago as well, so like I remember what it's like to not follow any of this stuff. So ask questions now. I think it's a good place for it.
I noticed like sometimes you pass the variable and automatically like you put the ampersand before, and the function takes as a reference. Sometimes you define on the function signature. This borrows.
Mm-hmm.
What's the magic there to? What's the magic there to make the? Is there a way to? I say. Like, even though the function signature says it borrows, is there a way to move with this signature? Because on the debug macro, sometimes you move, sometimes you pass a reference, right? That a macro
Yeah, debug isn't.
characteristic?
Yeah, the debug example that I use isn't great because there's some magic happening there. So I shouldn't debug these macros do a bit of magic, so it's not the best examples. I think we need to sort of construct our own examples out of borrow with vectors and borrow number, because fundamentally everything in the memory is a vector of some of U8. You know, it's just basically everything memory is vector. So I think it's better when we're learning this to, you know, let's not use macros.
Okay, so that thing just happens with macro, doesn't happen with functions.
What's that?
To be able to pass a parameter as a.
Oh yeah, the macros. Yes, the macros. That's right. I'm sorry. This is why it's confusing, because macros don't have types. I don't like macros are confusing. I mean, you know, macros are supposed to interpret whatever you're putting in there. So let's stick with actual functions. Let's do this.
All right.
Let's do this. Okay. Here's a new vector that I'm assigning that's empty. Yeah. So why did I put this stuff on the left here? Because I'm telling this vector constructor, yeah, to create an empty vector with the type, I need to, everything in Rust, you need to know the type of it. To create this vector of this type, U64 integer. This is A. And now I'm going to push onto A. I'm going to push number 1. So soon you'll learn about something called generic types, but push accepts is accepting U64 types for A. Yeah. So I'm gonna have to use a macro. Print line. I mean, I don't know what else I can use besides print line.
Push automatically know that this is or automatically assume that this is a U64 because it could be, I don't know, a U32 or whatever.
Yeah.
One.
So numbers have special treatment, of course,
Okay.
in Rust. So the correct way to say it would be to do this, to put a U64 at the end of it. Yeah, but Rust compiler makes some reasonable judgments, So if it's a number, if it's an integer that you've put in there, and you've assigned this as an integer type, it'll say, okay, we'll cast this into the right type. So there's some things with the type coercion that Rust will do automatically for you, like that. But it's very limited, so it's not like you
After everything I've seen before, I would have not expected that.
Yeah, right. Yeah, I agree with you. It's inconsistent, but it's inconsistent. But what I did here, being explicit, this I think is the right way to do it. The macros. I actually don't know if there's a function. What's the underlying function here? Let's look at this. Okay. Let me see. I've never done this. Let's see. Higher wire act here. What does this expect? Really? Really? What is it expecting? This is annoying. Yeah, I don't expect this to work. I've never actually used the underlying functions. I've always used the macro for print line. Anyway, we'll leave it. We'll use this for now. Yeah. Give me a second here. Okay. This is why I use debug all the time. It's just because there's some formatting and encoding things that Rust is very particular about, and the debug gets away from that. So what happened here? This is complaining that I didn't make this mutable. See, Rust always wants things to be immutable, so I had to actually assign it as a mutable variable. So now there I go. I've now pushed the number 1 onto there. I'm going to push the number 2 as well. And this is fine. Now, what do we want to do? Now we've got a vector. I've got 2 options of what I can do. I can either change it with a borrowed function or change it with an owned function. And let's take the prints out of here. I'm going to push number 5 on this one here. Let's keep it simple. I'm just going to have one number in the vec. Now what I want to do is I'm going to borrow. This one asks for a borrowed A to attach a 4 onto it. My compiler is complaining about this because, see, I'm just trying to pass a reference to A, right? But this function says I actually want you to send me a mutable thing because I'm going to change it. Yeah, so I actually need to also, besides it being assigned as a mutable thing, which can say just generally this thing can be changed, I have a function that is telling me I need you to change, I need this to be a, I need you to give me a reference that's mutable. Besides the thing actually being able to be mutable, I need the mutable reference to it. So that's what this does here. What's complaining? Cannot borrow is immutable. Why can't I borrow? Oh. Okay. So here I'm using a borrowed reference, a borrowed mutable reference to change it. It's one way of changing it. And then the other way of doing it, which is similar to our chicken fryer example, is by taking the owned number and changing it. See if I've made a mistake here somewhere. Value borrowed after move. Yeah. Yeah. Where did I change it? Oh, because it went out of scope. This last line isn't going to work, this debug, because
Yeah, that's exactly what we talked about, right?
Yeah, exactly right. Yep. Yeah. So I want to put a print actually down here. So debug. Just so that we see that it actually did something. Yep. Yeah, good. That is what I expect. And so again, yeah, so our whole example here was, let's use the borrowed number again. So now let's say I want to change that again. I want to put another number 4 at the end of it. This isn't going to let me because I sent it out of scope. I changed the ownership. I changed the ownership to the owned number function. And then when I want it back in the outer scope, in the main scope, and I try to do another change with it, it's not going to work. And no matter what I do with it, it's not that I'm trying to change it because with a reference. It's even if I try to change it with the owned one, it doesn't matter. Nothing's going to work because I've moved the ownership away, and I've actually changed the underlying data. Let me expand this again back to the Fryer example. So far, what we've been doing is pushing, is changing the memory. So so now let's do number Fryer. And I've got a borrowed, same thing, mutable vec. But instead of pushing, I want to actually change it completely. And so whatever I get here, I would want borrow to be a new vector of type 100 U64, no matter what happens. Sorry.
You have to
Vector.
dereference.
Wait, hold on. I need to. I'm going to do this the painful way. So let's do a new vector. I'm going to make a new vector. Hello. Push. Number 100. Type vec U64. Yeah. So I've got this new variable, but now I want to assign borrow to hello. I'm not changing hello in place. I'm not changing borrow in place. I want to overwrite it like we did with the Fryer. So it's different than these below, right? These below, I'm pushing stuff onto the vector. here I'm reassigning it. So I have to do the dereferencing, the chicken fryer dereferencing. So what did I do here? So I did simplify this. So I got my number fryer, and I need a mutable here. And so what happens is, so let's do it without. So what we expect here is only one thing to be pushed onto the stack. So here, business as usual, right? I started the vector with number 1. I borrowed it over here, pushed a number 4 on top of it. Cool. But now I'm going to put it in the number fryer and see what I get. So I get number 100. So it overwrote the other thing, but enabled to do that, I needed to dereference and really get the underlying object. So sorry, I know I'm talking fast. I'm doing a lot of things all at once for new people, but how are people feeling about this?
Hi, Odi. I think this is great. Thanks for doing this. It's my first time today.
Hey, Abid.
Just one quick question. Good to be here. Just quickly, I wanted to ask, do you need for these types to be mutable to dereference it like that? It's just like, from my understanding, other languages, I would expect it to work without having it mutable.
That's a good question, because I don't know if I've ever seen that.
I tried
well,
it. I tried it without. Didn't have success. Like starting with an immutable variable. I'm used to just like passing as a reference and not having to worry about mutability.
Yeah, in
But I
other
think-
languages, everything's mutable by default. So that's why it would probably work wherever you've seen this before. But if I tried to do this, I changed the mutability of it, the compiler is going to catch it, saying, dude, you're wanting to change this thing because you put a dereference on it.
It makes sense.
But like,
But,
why didn't you
question
pass
I'm
it as
asking-
a mutable?
Sorry,
Oh.
the question I was wondering about is like, if you go up to the definition of the variable you're passing, which is also defined as immutable, and
Yeah.
also remove that, like on the line number 5.
Okay.
I guess it's also being passed as, being defined as immutable. So if we remove this from the definition as well, there's no type mismatch anymore.
Well, but then I can't change it at all. Because then what I've done here is I've said this is static forever until the end of time. And so nothing's going to work here. There's no way that I'm going to be able to push anything onto it, change anything. Sure, I could I could make the types match the function signatures, but I'm not going to be able to. When I get to this here, here, push something onto something that hasn't been initially initialized as mutable, nothing can happen.
Yeah, so the vector is immutable, which means you cannot modify that vector in memory, right? But I'm wondering if the reference itself follows the same pattern. But by having let A, like this definition on line number 5, be the same, but also removing the mutable keyword from the function definition as well, and from the from the calling of function as well. So
yeah, so I mean, I can do something else. Like I could say, where did we do this? I mean, we had done this before, so like just owned over here, and I'm going to print it. So I'm going to do this here. O is a vector type U64. Yeah. This is kind of what you're saying. Can I just do just owned of A here? Abid?
Yeah.
Okay. Yeah, this is fine. This
But
will do whatever. But see, I've instantiated it as an empty vector, and it's printing out an empty vector like I would expect over here. But I'm not going to be able to change it. So if I wanted to then push something onto it, push, the compiler is going to complain.
all right, I'm wondering if you would dereference it like you did with the variable A there,
Sure.
and assign a new object to it. Like, would that be the same as pushing to it?
Let me see.
I guess whether or not you pass it as a reference, but without having it mutable.
I don't know how I would do this. It's going to give me a slice, and then let's see. I mean, I think this is going to no, this will work, but it's not going to change O. This is going to create a new assignment. This creates just an assignment. Doesn't have a size known at compile time. Yeah, that's another thing. Is that I would need to instantiate. Let's see. A cool fact. I'm gonna try and make this work for you, Abid. I'm gonna try. Let me see. But you know, I'm pretty sure we're doing an anti-pattern here. So let's see. I mean, I might learn some. I mean, this no, because these types are different. Let's see. Yeah, it's asking for a reference. It's saying it's what I'm doing here is creating a reference. So I don't know how to do what you're suggesting. So I think the answer is no. There's no real way of using a dereference in a thing that's not mutable.
So
I don't think.
I'm just like to explain what I'm thinking about. It's not. I understand that objects that are passed in this way, or maybe in the Friar example, where it's passed like without the mutable type, it's basically not going to be changed, which is the actual object in memory, right? I'm just wondering if the reference itself is mutable, since or immutable, since you're able to change the reference by this star sign next to the borrow. But
yeah,
I'm just
so let's
thinking like if you remove this mutable from 3 different places, which is this line 45, and also when you call the function and you define the variable at the same time, would it still? I'm just reverting back to the number Friar example.
Okay, this one here, yeah. Let's see. I mean, I can do different things to borrow. You know, let me see. If I push, so like I said, like a number Friar. So number Friar is a derivation of the borrow mutable here, where I'm pushing something onto the borrowed. Yeah, but the difference is here. I want to completely overwrite it. Is what had to happen differently, which is why I would need a dereference. I can do a bunch of things with if I have a mutable borrow like this. There are plenty of things I can do to this. A lot of methods I can change, but I'm not able to do. I mean, let's do a test here, but I don't think I'm going to be able to do something like this. Try this. I don't think this is going to do anything. Borrowed number. Or this might compile, but it will not do what we expected. Yeah. Wait. Wrong place. Yeah. I start getting into weird Rust things where now it's just telling me, look, you're trying to instantiate something and then borrow it at the same time. And it was, yeah, I mean, this is, we'll talk about this soon, but like lifetimes, I'm violating some lifetime things. So not sure, Abed, I'm not sure I'm helping you here. I'm probably confusing more people here.
Can I also ask you to try one thing just for the sake of closing this idea? If you go to line like 45 from the signature of the function and remove mutation keyword.
Yeah.
From that, so keep it as a reference like that. But also let's go up to the test that we're doing, and also remove the mutation from passing the value and from the definition as well.
Number Friar, right here.
Yeah.
Okay, so what we're trying, okay, I'm listening.
And also in the definition where you say let also the mutation from there as well. And I'm wondering if that case is going to fail. Because if I understand this correctly, you're actually not modifying the object at all. You're just replacing it, which doesn't really say you need it to be mutable, because mutable refers to the vector itself, not to how references work, like going from stack to heap. Does this fail?
So I think it's going to get caught
I
right
really
here.
expect to fail because it's actually changing the value in the memory.
This is, you're telling it right here to change that piece of memory. You know, the thing is, okay, let's run it. No, this is failing somewhere else. Forget this. Yeah. Here's what the compiler says. This keyword, borrow, is a ampersand reference. It's a reference. So the data it refers to cannot be written. So yeah, the compiler.
That's the purpose, to protect the memory, right?
That's right. Yeah. Because if you had cases like, because you do have this in other languages, and you're right, Ahmed, but if you have stuff like this happening, first of all, I think it's actually a source of a lot of confusion for developers when you sometimes have this like variable that keeps changing, even though you don't expect it to be changing in certain cases. And then like debugging it is like a nightmare. But if you also have stuff like this, you might get into situations where the memory doesn't get. For this to happen, you need garbage collection, right? And then the memory isn't getting. It might not be getting cleared all the time, and then you're open to all the sort of the software vulnerabilities that come with garbage collection not working correctly. I'm not an expert on those things. Like I'm really naive about this stuff, but as I understand the design of Rust is really to prevent those types of exploits. Is that helpful, Abed? Was that?
Yeah. Yeah. Thanks for explaining this. Actually, it makes sense that from also like programmer point of view, you define something as a mutable, and then you just don't expect anything to change anytime. Which also, even if it's just a like a pointer to the object, find it
Yeah.
incorrectly. Thanks.
Yeah, the pointers. Yeah. Oh, maybe we'll leave it there. This is, you can see how I'm like trying to play around and experiment and scratching my head on stuff. It's because it isn't intuitive, you know. I've been doing this for some time, and look, I'm not a great engineer. Don't know anything about programming language theory, but you know, this stuff isn't automatic. You know, how to do the borrow checking and stuff. So you just eventually learn patterns and habits around it, and you know, the patterns that exist in Rust I like. They're interesting because you end up writing safer things.
One of those things we feel like, I understood, and then tomorrow, wait. Let me check again. And then once we crack it, maybe we just do it. We kind of do it on automatically, and then when we have to think, we kind of take another time.
Sorry, your audio was cutting out a little bit. Sorry.
I said maybe it's one of those kind of things that today we feel like we understood, and tomorrow we might have to try again, and at some point we understand, and we might do an automatic, and then later on, if we have to think on the details, we might have to test again.
Yeah, and like I said earlier, take your time with this memory stuff in Rust. Like if it doesn't make sense to you, don't move forward. You know, because then you're just going to be, like me. Okay, you're going to be imitating things for a long time that you're not going to understand, and so that's, you know, don't do as I say, don't do as I do. You know, because I would go out. That's what I did. I went out and just tried to write stuff in Rust, and then the other people here on the team that actually knew Rust, they're like, "What are you doing?" Because I didn't take any time to like really deeply understand the memory stuff. So that's my words of wisdom. Take time with the memory and borrow checking stuff, and then you'll learn to like it. You'll learn to see that it's a good choice for a language, and you get a lot from it that you get for free. You know, this memory safety stuff that you'll learn to appreciate.
In my case, I started to learn this. Still, I'm a beginner. I could probably, because I know all the programming language, could probably just pick up and do a project from beginning to zero. But I don't really want to bring my habits from other language to Rust. You know.
Yeah, it's okay. Rust isn't going to let you bring your other nasty habits from Python. You know. Yeah. So, but here's my suggestion: is it's like everything in life, right? Is you can only really understand this by doing it. So everybody has homework for next week. It's the same as last week. You know, go and fix a memory. Go and fix a control flow issue. You know, with match. And then while you're there, look at how the memory is being used. Go look and see how the references are, and poke around. Change something. Take an ampersand off somewhere and see how much the computer starts shouting at you.
Thank you.
Super. I'm going to break now in a couple minutes. Are there any last questions from folks?
Maybe, yeah, maybe a stupid question, but what I would find very exciting is if we could look for, let's say, for places in the code of OL where we could find this kind of things, or we could talk about this stuff. I mean, it's of course it's easy if we have very small little examples like we've seen today, but it would also be very interesting for me to see this in action, let's say, in OL. I mean, it's not a must, but would be
Yeah.
interesting.
Very good. That's a great suggestion. We're what are we on the third, fourth day of this? So we might want to get just to the next thing I wanted to show everyone, which is just classes and construct and methods on classes. And then I think that will make it easier for people to navigate some code. And then I think it's great. Then I can pull in people here can choose the tool, something that people use a lot, maybe the transaction sender or the tower or something. And then we can walk through. I mean, look, I wrote a lot of this code, so there's going to be lots of opportunities for improvement. Okay, so we'll just go and find something and fix it in real time.
Yeah,
Fantastic.
that sounds good. Oh, yeah, go ahead. Michael, do you have something to say?
No. I mean, that was my suggestion, and
Okay.
yeah, I'm looking forward to that, and also probably looking forward to hear more from OD why Rust is an excellent. I mean, there is something to Rust, right? It comes out as the most beloved language among developers, like in every survey since a couple of years or something. So, and I mean, there must be reasons for that, and I don't know,
It's,
OD, do you love it too? Is that, or
no,
is
I
it
don't
for you
love.
just a tool?
I don't love languages. I'm not even an engineer really. So like, I'm interested in economics stuff.
Okay, so
And so like,
just a tool.
yeah, no, I've been doing engineering for 15 years, but you know, I see engineering as a tool, you know, to do other things. I'm like, I think some people find it surprising when everybody's excited about the Move programming language that Facebook invented and that we stole. I say, you know, it's a tool, and you know, it's either going to serve our community, the entrepreneurs in our community, or it's not. And so I don't want to be married to it. I have no interest in being an evangelist of it if it's not going to work, and then we'll go do something else and win with something else. I happen to think Move is a great language for smart contracts, and I think it's going to help our developers a lot. I think it's great. Same thing for Rust. I mean, Rust, I see it being used throughout blockchain on all the top projects. It is, you know, top security researchers in cryptography want everything done in Rust, and so there's a lot of, you know, a lot of resources and momentum around Rust so that it can be productive in creating a safe system. That's how I look at it. And so I look at it from a very narrow lens of, you know, I'm not an engineer. My career isn't about engineering, becoming an engineer and going to the next thing. My career is building blockchains as tools to help entrepreneurs do things in the world. So Rust has a lot of tooling there. A lot of everybody in blockchain is using Rust for that. Facebook built this project from scratch. Facebook didn't import anything pretty much, except for like very low level Rust things. They wrote the cryptography libraries. Well, no, they're using Dalek. So besides, you know, but they wrote a lot of the cryptography tooling and such from scratch with Rust. So it's just something I'm stuck with, you know, because this is where the project is at, and this is what we're going to do. So just so there are no illusions, I'm not an evangelist of Rust or Move. It's my job, right? I think Rust is great and I think systems level developers, engineers think it's great because of sort of the alternatives that you have. And really the alternative is C, C++. And, you know, yes, there are systems done in Java, but not really low level systems. And so and Golang is an alternative, and people like Golang as well. But Rust gives you more safety features than Golang, and it's a little bit uglier to use. Rust, you have to get around these initial ideas that are very annoying. But it saves you in the end, and you get all the modern tooling for languages. So the Rust package manager is great, is really, really great. The Rust testing harness is really, really great. Better than stuff that you have because in Node and Python and whatever, all that stuff is add-ons. It all came later. It's all external to the language and basic language tools. And in Rust, that's all really part of the basic language tools. And so like package management, dependency management's much better with Rust than almost anything that I've dealt with. And testing is great. It's better than anything I've worked with. Yeah, and the language, you feel safe using the language. The compiler is very annoying, but you feel like you're not making silly mistakes, and you don't want beginners like me. You don't want I'm not a deep engineer, deep tech engineer. Like, you don't want me programming systems level stuff, honestly. But it feels pretty safe, for the most part, because the compiler catches a lot of stuff. Now, I'm not saying that there are not going to be mistakes. There's going to be lots of mistakes, and there are going to be even exploits, and zero on the future. But this is as good as we could get, Does that help? I mean, I'm rambling a bit here.
No, it's interesting. It's very interesting.
Thank you.
I have one suggestion,
Yeah.
small suggestion to improve a little bit the debugging during streaming. Maybe it would help to split the window vertically and have the function definitions in one window. So whenever we go